Alright, I'm actually recording this time, so I'll have to redo this entire problem. So this is number 53, number 54. I accidentally skipped in my last video. This is a quadrilateral that's inscribed on inside circle A, and all the points of this quadrilateral, D, C, F, E, are on the circumference of circle A. Right? So let's, it gives us angle D of 75 degrees. And then it wants us to figure out angle CAE. Angle CAE. So that's this one. Angle CAE. Wants us to figure out that one. It wants us to figure out angle CFE. Wants us to figure out this one. Question mark. That's this one. And it wants us to figure out arc measure, the arc measure of angle CDE. Wants us to figure out the long arc of C, D, and E. So this whole arc. Okay, so let's get started on that. Alright, let's go zoom in and get to work. Okay, so remember what an inscribed angle is. Okay, an inscribed angle is an angle whose vertice is on the circumference and shares endpoints with the central angle. Right, so if you see here, EAC is a central angle because its vertice is the center point because it's the circle A, and E and C are on the center point or on the circle. Right. It also so this is a central angle. So CAE. So this, focus please. So this is a central angle, okay? And this, CDE, is an inscribed angle of this central angle CAE. And the relationship of a central angle and its inscribed angle is that the inscribed angle is 1/2 the central angle. So if this purple angle is 1/2 this orange angle, then you can say that angle CAE equals 2 times angle D, which they're just calling angle D at 75. So it equals 150. Equals 2 times 75 equals 150 degrees. Right, so this is like 150 degrees. All right. So what about this measure of angle CFE? Right, also known as angle F. This is an angle opposite. This angle is opposite of This angle is opposite of the 75-degree angle inside of our quadrilateral. And angle's opposite, so D is opposite angle F inside of a quadrilateral. Therefore, it is supplementary. They are supplementary. Right? So if they're supplementary, right, then you know that angle F equals 180 degrees minus 75, which equals 105 degrees. Right? So I'll go over here. This is 150 degrees, and this is 105 chunk over here around in and about our circle. Okay, so what about the arc measure? What about this arc measure of CDE? Okay, well, this arc measure is half, well, not half of the circle, but it's the portion of the circle that's not encompassed by this other portion of the circle opposite of 150. All right, so if I look at this angle, right, this angle here is going to be 360 degrees. 360 degrees minus 150. So that's going to be 210 degrees. All right, let's make that purple. This angle is going to be 360 minus 150, which equals 210 degrees. 210 degrees. Okay, so since that equals 210 degrees and this is a central angle, its respective arc is 210 degrees. So that's how you figure that whole thing out, because it's 360 minus 210. So it's 210 degrees. You could have also said, hey, this arc is 150 degrees, and this entire arc, this entire circle is 360. So arc C, so this arc CDE is equal to 360 minus CE. That one would have worked, or 150 minus, 360 minus CE, which is 360 minus FE. Either one would have worked. So that's that one. Okay, moving on to this one here. I gotta probably zoom out a little on camera to read the whole thing here. Okay, got an International Space Station with the drawing. Right, that is 248 miles above the Earth's surface, and the angle formed by the two tangents is 140. This is 140.4 degrees. Okay. What is the measure of the arc? So trying to find this measure of the arc between this and this. Okay. And two tangents. What is the measure of the arc of the Earth that could have viewed the International Space Station going over forward? Okay, so this is the. All right. Let me think on this one for a second. I gotta read this whole thing. What they mean about this? It passes over the Earth 245 miles above the Earth's surface. So this must be 245. Let me take a look at this and think about it for a second. Alright, so this might be a new concept for most of you guys. This was a chapter 11 thing. Alright, so if I take a center point of the Earth and I draw a radius to each one of these tangent points to where that tangent would be, I know that this would be a 90-degree angle at each one of these points. Right, so that would end up being 180 degrees, and the sum of those two angles equal 180 degrees. So we've taught you guys that diagonally the sum here, because these are 90 degrees, these 90-degree sums here, that these have to equal 90 degrees as well. Okay, so since those have to equal 90 degrees, then, and that this arc here is a central angle, then this arc equals that arc as well. So this angle is supplemental to that angle. Okay, so you have to kind of draw some lines there. So you can figure out that this angle, we'll call this angle green, I suppose, or angle X. We'll just call it this angle, I guess. We'll use this angle as psi for a long time. Our central angle is going to be simply 180 degrees. 180 degrees minus 140.4 degrees, which is 39, like 40 points, yeah, so it's 39.6, I think. 180 minus 40.4 equals, yeah, it equals 39.6. 39.6 degrees, which is this angle, and since this is a central angle, the arc measure of this is also this as well. So that is the answer to that one. I hope that makes some sense to you guys, and I'll post this right away.